All right, patrons, let's go ahead and go on to the second lesson on this chapter, this unit, and go ahead and start doing similar polygons. And just like yesterday, let's go ahead and fold this in half long ways. Make sure that page 1 is right there on the beginning. 1 on the top, on the bottom right. Flip over, you've got the X on the back. That's what we'll be gluing later, just like yesterday. Okay, so yesterday's assignment, we fully focused on proportions and ratios. Okay, I hope that you remember yesterday that proportion is just a fraction equals fraction, and we use cross multiply and solve, not cross multiply and divide, unless that's the solve step is dividing. So anyway, we're moving on to similar polygons, and to start off with, we've actually got 2 new symbols. Now, I forgot to put the second one on here, so you're going to have to draw it in there. And that symbol looks like this. It is kind of a sideways elongated S, okay? And so that means, and then we'll put our blank there. So first off, this thing right here, it looks very similar to a Greek alpha if you've ever studied the Greek alphabet, but it's a little bit more elongated than an alpha symbol. What that means is proportional. Now, when something is proportional, what that means is I could set it up in a proportion, and whenever I cross multiply, the left is going to equal the right. So here's what I mean by that. If I have 2 over 5 is equal to 4 over 10, well, I can use the cross multiply. 2 times 10 is 20 equals 5 times 4 is 20. What that means is that 2/5 is proportional to 4/10. If these two had come out to different things, that is not proportional. So I could say that these two are proportional. Let's say that I'd done something different and had 2/5 is equal to, let's just use something we know is not going to work, 3/10. Well, 2 times 10 is going to be 20. 3 times 5 is 15. And so that's not proportional. So I'm going to be using this symbol several times throughout the unit, and so we need to go ahead and start getting used to that. Second one, this one means similar. And we will get to the definition of similar, S-I-M-I-L-A-R, sorry, my handwriting is horrible, down on this section right here. Now we've covered congruent. Congruent means something is the same size and same shape. In particular, we know that all the corresponding angles are equal to each other, as well as all of the corresponding sides are equal to each other. Well, similar or similarity is similar. It's a similar concept to being congruent, except that in this case, corresponding angles must be congruent, but corresponding sides must be proportional. Now, this is slightly different than you've seen before, because what this allows for is not just same size, same shape, but they can be the same shape, but different sizes. Okay? Now, also a little bit of a notation idea here. This symbol is similar. This symbol is equal. If you combine the two of them together and put a similar sign above equal, you get congruent, which is literally telling you that, that these two shapes on either side of it, or these two figures, are literally the same shape and the same size. So that's where that symbol comes from and why we've been using it all year. All right. So let's go on to what we actually do with this, okay? You would see it written something like this. Trapezoid ABCD is similar to trapezoid EFGH. And just like in our congruency statements, similarity statements are going to have corresponding parts, and the roadmap works as well. So A corresponds with E, and then C corresponds with G, and so forth. So we said that corresponding angles must be congruent. We're going to do the angle section here first. So, based on this, I know that angle A must be congruent to angle E. Angle B in the second position must be congruent to angle F. And let's go ahead and mark those in as we go. Angle A is congruent to angle E. Angle B is congruent to angle F. Angle C is congruent to angle G. There's G and C. And then angle D is congruent to angle D is last, and then angle H is last. So 1, 2, 3, 4, 1, 2, 3, and 4. Now, the sides are also going to have corresponding parts. And remember that we just take all the different pairs all the way around. So we start with AB, side AB, and side EF. And so side AB and EF, they're not equal to each other, but they are proportional, which means I could set up a proportion and the whole thing would work out. We also know that BC, positions 2 and 3, are going to match with FG, positions 2 and 3. And those are, again, proportional. All right. Then we've got CD, positions 3 and 4, are going to match with positions 3 and 4, GH. And then put a proportional symbol there. And then for our very last set, we're going to say that we're going to do the wraparound. We already did AB, BC, CD. Now I got to wrap around to D and A. So DA, and then over here we've got HE, and those are proportional as well. Okay, now for our question. Don't write this. First question of the day. First off, what does this symbol mean? All right, and number 2, what does this symbol mean? Number 3, what does this symbol mean? And then number 4, what does this symbol mean? All right, hopefully you got all those right. It should have been proportional, similar, equals, and congruent. And hopefully I did not mess up on the answer key like I did on the first one. All right, moving on to page 2. One of the skills we're going to need is to be able to look at two shapes and identify whether or not they are similar to each other. Okay, so the first thing you're going to have to do is to identify all the corresponding sides and angles. Now, on some of these, that's really easy to do because they are already marked. In others, you might have to actually work at it, in the case of like an isosceles triangle. But I'm not going to give you anything that you don't have the experience to identify already. So, corresponding angles must be congruent. You already know that from the last page. And then corresponding sides must be proportional. Now, in order to do that, what we're going to do is to check for a common scale factor. Now, the scale factor is going to be nothing more than one side of the proportion, so one of the two fractions in reduced form. So we'll actually practice that when we do these two. Okay, so are the quadrilaterals similar, and if so, what is the scale factor? What we're going to do is first off check to make sure that we have corresponding angles that are congruent, which was our step number 2 over there. I can see that these two angles match. These two angles match. 1, 2, 3, 1, 2, 3, 1, 2, 3. These match, and 1, 2, 3, 4, 1, 2, 3, 4. Okay, I don't know what their measures are, but I do know that there are sets of corresponding angles that are congruent. Next, I've got to check every single set of sides, every single set of corresponding sides, to make sure that they all reduce down to the scale factor. So here's how that looks. Let's start with our the 1 and 2 marked angles. That's going to be 2 over, on this side, the 1 to 2 marked angle is 4. Now, that's going to reduce down to, well, 1/2 or 0.5. Forget that point was there. Now let's check the next one. From 2 to 3 is 3 over, on this one it is 6. That reduces down to 1/2. From 3 to 4 on this side, I'm sorry, this side first, is 1 over, from 3 to 4 here is 2, which is already reduced. And then on this one, from 5 back to 1 is 5 over, here is 10, which reduces to 1/2. Notice that every single one of these reduce down to the exact same amount. So yes, they are similar to each other. And the scale factor is equal to whatever this reduced fraction is. Now, I said that what this proportionality or the similarity means is that the sides could be proportional to each other. What you'll notice is that if you took any set of these ratios and let's just take 2 over 4 and 5 over 10. I just picked that set and that set. Well, 2 times 10 is 20, and 5 times 4 is 20, so it worked out. Hey, that's the exact same one I used there. That was not intentional. All right, let's try this one. Are they similar? Check our angles first. Go to 1 mark, 1 mark. Go to 2 mark, 2 mark, and a 3 mark, 3 mark. Okay, I got corresponding angles. Now let's check these sides again. Here we're going to say ZQ, which is our 1 to 2 mark, is 18 over 1 to 2 is KP, which is 12. Now 18 over 12, they're going to reduce down. Let's get a common factor of 6. So factor out the 6, and I've got 3 halves. Now let's go from 2 to 3. QT is 24 over 2 to 3 is 16 on this one. So common factor on this would be they're both divisible by 8. So 24 and 8. 24 times 8 is 3. Divided by 8. 16 divided by 8 is 2. Hey, same thing. Now let's try the last set from 3 to 1 is 21 over, from 3 to 1 is 13. And 21, the only factors are, what, 7 and 3. 13 does not go into it, so this one is already reduced. So now we have 3 halves, and then this guy right here. It only takes one. If it's anything different, it is not similar. So what that means is you don't have to check every single one of these. As soon as you get one that is wrong or one that is different, you can go ahead and say that it's not similar. However, if they keep on lining up and being the same, you got to check them all the way through. It only takes one to be not similar. Okay, sorry for that little blip. I had to do a cut in the video because I realized the first time I was going through that there's a mistake in this problem that we need to fix, and I didn't want to have you guys watch me figure it all out. So I cut out about 15 minutes of this while I was trying to figure out exactly how to do it. Okay, first off, the first place I messed up is that should not be a kite. Also, this URST, those letters are in the wrong order. It should actually be UTSR. So go ahead and correct that for me, and that way we don't have any problems. Okay, so anytime that we have two shapes that we are told are similar, then we can assume that there is a scale factor. So one of the things that we want to try to do first off is figure out what that scale factor is, because we're going to need to use that scale factor in order to determine the lengths of some of these missing sides for X and Y. So the first thing I want to do is look at, let's see, just trying to find the one where it matches up. Like for example, QP is going to be congruent to UT, which matches with this Y down here. That's not going to help me come up with a scale factor because I've got 15 and Y, or I've got a variable in there. Also, let's see, I've got MN has a value. MN is 18, which matches with SR, and SR is 30. Now, since I have two values, 18 and 30, well, that's going to give me the scale factor I'm looking for. Now, I also mentioned that anytime that I make these fractions or these ratios, I like to give myself a little roadmap of which one's going on top. So in this case, I'm always going to be doing left over right. And when I say left, I mean the left-hand shape will always be in the numerator and the right-hand shape will always be in the denominator. So finding the scale factor is going to be MN, which is 18, divided by SR, which is 30. Now, in order to get a true scale factor, I need to simplify that. 18 and 30 are both divisible by 6. So divide out 6 from 18 and I get 3. Divide out 6 from 30 and I get 5. So my scale factor is 3/5. Now I'm using this 3/5 for the rest of my calculations. Well, not all of them. I won't need it for the last one. Okay. Now let's go ahead and first of these three boxes is to solve for x. X is on side NP. NP is going to be similar to or proportional to positions 2 and 3, which is TS. So the way that I use this statement to solve for a variable is to take the fraction for NP. NP is x over, well, I guess it's not, yeah, NP on the left, TS is 25, so x over 25 is equal to, then I put my scale factor in, 3/5. Sorry, I didn't explain that very well. Just to go back for that, I apologize. We know what this is. NP is proportional to TS. This value for NP goes there. The value for TS goes there because NP is from the left and TS is from the right. And then on the right-hand side of the equation, I'm just using the scale factor. Okay. Now when we cross multiply this thing, 5 times x is 5x. 3 times 25 is 75. And now we're going to divide that, and that's not one I can do in my head, unfortunately. 75 divided by 5 is 15. So the x value is 15, which means this side is 15 long. Let's try y, and hopefully I can explain it better this time. All right, y has a value of, or it comes from TU, and TU is proportional to, looking at my road map up here, UT is right here, so that's going to be QP. And now I'm going to take make a fraction out of these two. One from the left is going to go first. And even though I wrote TU here on the left, I still need to make sure that the shape on the left is always going on top because I always had left over right. So it looks like that's QP. QP is going to go on top. The left one is TU, which is y, and that equals the scale factor. Okay, so 15 is on top because it's from the left-hand quadrilateral. Y is on bottom because it's from the right-hand quadrilateral. Okay, and now let's cross multiply. 3 times y is 3y. 15 times 5 is, I'm going to cheat. I was thinking 75, but I just wanted to be sure. And then we're going to divide by 3 and get y equals 25. Okay, sorry once again about that cut. I was just second guessing whether that should be 25 in my head, and just want to verify that, yes, this is all right. So let's go ahead and move on to Z. Okay, so Z is going to be the measure of angle M, which this one is going to be simple enough. If the measure of angle M is equal to, well, M is going to equal R. So the measure of angle R. Well, that one's going to be easy enough. And so if M equals R, measure of angle M is going to equal, well, actually that's going to be your last question, and we're going to finish this thing off. What's the measure of angle M if M equals R? All right, Patriots, that's it. Have a good day, evening, wherever you're listening to this right now. But I guess just good luck on your assignment.